Hello, Colanet Africa online student, and today we are going to have electrolysis, which is our third lesson. So we are going to look at an experiment, and in this experiment we shall be using molten lead 2 bromide as our electrolyte. The experiment should be done or carried out in a fume chamber, cupboard, or in open air because some product produced like bromine is poisonous. Apparatus include crucible, a pipe crate triangle, electrical current, that is you have battery, you have a circuit, bulb, crocodile clip, and electrode, which now constitute to electrical circuit. Then you have the Bunsen burner to molten the lead to bromide. Chemicals required is lead to bromide. Procedure: fill a crucible up to a third with lead to bromide. Observation: when you connect the circuit and then you hit the lead bromide, this is observation that will be seen, that a reddish brown bromine vapor is produced at the anode because bromide are negatively charged, so it will be attracted to the anode, while the gray beads of lead metal are formed at the cathode because the lead are positively charged, the lead ions, so they will be attracted to the negatively charged cathode or the electrode. Bromine gas and lead metals are produced as a result of decomposition of lead to bromide by electric current. So decomposition means breaking down of lead to bromide into lead and bromine. So that is what we call the electrolysis. Lead to bromide is an electrolyte. So definition of an electrolyte is a substance which, when melted or dissolved in water, conducts electricity and get decomposed or broken down by the current. So one, it should conduct electricity, then be broken down by the current. The process of decomposing an electrolyte, bypassing an electric current through it, is called the electrolysis. So here is the circuit. We have the switch, the battery, the cathode, we have the anode, and remember the anode, we said it is connected to the positive terminal, and then the cathode to the negative terminal. We have the bulb, we have the direction of the electrons moving this way, and then the current moving in the opposite direction. Here we have the source of heat and a Bunsen burner where it is going to heat the lead bromide to make it molten to allow free movement of ions. The positively charged ions are called cations. So the positively charged, for example, in here we have lead ions which are positively charged. So the positively charged ions are referred as cations, and the negatively charged ions are called anions. So the negatively charged here are the bromide ions, which are negatively charged, so they are known as ions. Don't confuse between the two terms. To make it clear, during electrolysis, cations move to the negative electrode cathode. So cations, so the cat here, we can relate it to the cat or the cathode. So the ions moving towards the cathodes are known as cations, and since they are moving to the negative electrode, so the cations are positively charged, and the anions move to the positive electrode. So the ions, okay, are moving to anode, okay, anions. So the anode, we know it is positively charged, therefore anions are the negatively charged ions. The changes that occur when lead bromide is electrolyzed. At the cathode, which is negatively charged, The positively charged lead ions get attracted to the negatively charged cathode and migrate towards it. On reaching the cathode, the lead ions gain electrons to form electrically neutral atoms of lead metal. So they usually gain electron. The metal is deposited as gray beads on the cathode as indicated below. So you'll find this one is ions of lead. So it will attract 2 electrons and you'll form the lead atom. So this addition of electron is referred as reduction. So what is happening here? It's a reduction process. At the anode, which is positive charge, the negatively charged bromine ions get attracted to the positively charged anode and migrates toward it. On reaching the anode, the bromine ions loses electrons to form bromine atom, as shown in the following equation. The bromine atoms combine to form diatomic, meaning 2 atoms coming together to form a molecule of brown bromide gas or reddish brown bromide gas. So this equation, we have bromine here, and bromine will lose now. Okay, I hope you can see this difference. This one, it is gaining electrons, and this one is now losing the 2 electrons. That is why it is on this side. So it loses an electron, and since we want to form the atomic molecule, then it means we need 2 atoms to make that. So therefore, we'll have bromine gas as Br2. Therefore, to balance the equation, you need 2 of electrons here, and meaning because these are 2, then you have to put a 2 here to balance the number of bromine atom. So that is how it is formed. Lead bromide or lead 2 bromide is an example of binary electron. Binary means bi means 2. This is because its melt contain 1 type of cations and 1 type of anion. So it have 1 cations. The cations here are the ones which moves towards the cathode. So the cations, they are the positively charged, that is the lead 2 ions, and the anions are the ones that moves towards the anode. Therefore these are negatively charged, and these are the bromide ions. So here you have binary electrode, we have the cathode equation, anode equation, and it is important also to note the colors of the products. Now here we have lead bromide, 2 bromide. You find that at the cathode, the lead will gain 2 electrons to form lead atom. Then in lead 2 iodide, the same will happen. In sodium chloride, sodium will gain 1, and since the chlorine here will have to form a diatomic molecule, it has to form a gas. So what happen is that the chlorine will lose 1 electron, but we need 2 chlorine to lose so that they can form the gas. Therefore, the 2 electrons lost here will be gained by the sodium here. Therefore, we need 2 electrons here so that they can neutralize the sodium ions. Therefore, the balancing goes like that. Then aluminum oxide, we have this one at the cathode and this one at the anode. Then the colors are indicated there. We have the reddish brown for bromine gas, purple for iodine gas, greenish yellow for chlorine, colorless oxygen, greenish yellow for the chlorine. So we have magnesium chloride, that is a reaction, and this is what will be happening at the cathode, and this is what will be happening at the anode. The same concept will be applied in electrochemistry in Form 4. Now, it is good to explain how you balance this equation. Binary electrodes, for example, we have lead 2 iodide. The formula is that because lead 2 has a valency of 2, lead has a valency of 2. So the interchange where iodine, which is a halogen in group 7, has a 1 valency. So interchange will form that formula. So at the cathode, this will happen, that the lead 2 will gain 2 electrons, and when it gains 2 electrons, they form lead solid. On the other side, that iodine will lose 1 electron. And since this will lose 1 electron, it also need to lose another one so that we can form the iodine solid, or it has to, they don't exist as atoms. So these 2 lost electrons at the anode will be gained by the lead ion to form the lead atom. So this should be balanced. Whatever is lost there will be gained on the other side. Whatever is gained here must be lost by the other, so that the equation is balanced. Therefore, in this case, you put a 2 there, and then you have the 2 to balance the whole equation. Now let us look at the other example. And the bivalent electrode has 2 ions, cations, and the lead ions, which are the cations, will be attracted to the cathode and will be attracted to the anode. This we have explained. From the formula, maybe a more clarification, 1 lead ion requires 2 iodide ions. That's the formula of the lead 2 iodide. The lead ion shall gain 2 electrons to form lead metal, and the 2 electrons will be lost by the 2 iodide ions. Now let us look at sodium chloride. In sodium chloride, at the cathode will have the sodium ions, and at the anode will have chloride, because the chloride are negatively charged, so they will be attracted to the anode. Therefore, the chloride ions are referred as anions, while these ones are referred as cations attracted to the cathode. Therefore, in this case, you need to form a gas. Chlorine will lose an electron because it is in group 7. But it also needs to lose to make a gas, because chlorine does not exist as an atom. So it means it will lose 2 chloride ions will combine to lose 2 electrons to form chlorine gas. The lost 2 electrons will be gained by the sodium, because sodium has a valency of 1 group, it is group 1. Therefore, 1 sodium atom or molecule ion will gain 1 electron. But since chloride lost 2, then we need 2 electrons here. To make that, it means 2 sodium ion will combine, gain 2 to form 2 sodium atom or sodium metal. Sodium ions will be attracted to the cathode, this explanation. Then, while chloride ions will move to the positive charge electron and positively charged anode. From the formula, you'll find that we have this formula: 1 sodium combined with 1 chloride ion, but cannot exist as an atom, that is chlorine. Therefore, it needs to form a gas, so it requires another atom to form Cl2. The 2 chloride ions need to be oxidized, losing electrons to form 2 chlorine atoms that combine to form chlorine molecule. Therefore, the lost 2 electrons will now be gained by the 2 sodium ions to form 2 sodium atoms. Hence, the above balanced chemical equation, this one. Then we have another example, aluminium oxide. From the formula, you'll find that we need 2 aluminium atoms and 3 atoms of oxide ions. So you'll find that we have Al2O3, because aluminium is in group 3, so the 3 will be here, and oxygen will be, the valency of 2 will be there. Therefore, the two aluminium ions will gain 6 electrons to form 2 atoms of aluminium metal. So the two will require to gain 6. Why? Because each will gain 3 and the other one will gain 3. So a total of 6 electrons to form the two aluminium atoms. The 6 electrons lost by the oxygen will reduce aluminium into form 2 atoms. Now, if this one is from the 2 atoms of aluminium, the 3 oxygen now will be required to lose 6 electrons to form 3 oxygen molecules, because we have 3 of them here, meaning this one, the lost here, this one which are gained here by the aluminium will be lost by the oxygen. And since 1 oxygen will need to lose, or 1 oxide ion we need to lose 2, then it means we require 3 of them, so that we have a total of -6 or 6 electrons. So the 6 lost electrons by oxygen will reduce aluminium into form to 2 aluminium metal. Note, the number of electrons lost and gained should be equal. So this is the number of electrons lost, and this is the number of electrons gained. They should be equal so that the equation is balanced. Application of electrolysis. Electrolysis process is applied in extraction of metals such as sodium, magnesium, and aluminium by electrolysis of molten compounds. Especially this reactive metal can be obtained through electrolysis. Then purification of metal. You want to purify metal, you put it in a molten form or dissolve, and then you do the electrolysis. Electroplating of metals such as iron to improve their appearance to prevent corrosion. So electroplating, it's like coating of metals to prevent corrosion or rusting. Then we have manufacture of pure chemicals such as hydrogen gas, chlorine gas, and sodium hydroxide. So you can obtain these chemicals through electrolysis. Finally, we have an assignment. The questions are there. Make sure you read and understand, and then the answers are provided in the note section. Thank you and wish you the best. And then remember, there is a timed exam on this topic. We wish you success. Make sure you have a stable network. Thank you and bye.